Hello students, welcome to my channel Physics with Ras. So today we are going to learn about waves. As you had seen waves in the previous video, we are going to discuss continuation of this topic. So in the basics of the waves. So now in this video we are going to learn about the between phase difference and path difference, as well as we are going to learn the relation between phase difference and time difference, as well as to represent the expressions for energy, power and intensity of a wave. So let's start this topic. As we had seen, now we know that the phase of a mechanical wave is being represented as phi equal to omega t minus kx. So here we are going to represent the phase in terms of a path when a wave is being propagated from one position to another position, like this. So here let us consider two different points. I am going to consider a point of x1 at this location as well as x2 at this location. Now we are going to represent the path difference between these 2 points. So for that I am going to consider phi1 equal to omega t minus kx1, and at this position the phase is being represented as phi2 equal to omega t minus kx2. Then the phase difference between these two waves is being represented as delta phi is equal to, after that omega t and omega t gets cancelled because of phi 2 minus phi 1. So here we get k into x1 minus x2, where x1 minus x2 represent delta x, where delta x represents the path difference between these 2 points. Whereas we know that k is a wave number and the value of k is being represented as 2 pi by lambda. So here we can represent delta y is equal to 2 pi by lambda into delta x. Observe that for a path difference of lambda, there is a phase difference of 2 pi in the case of a wave. So when we consider that a wave has been propagated in the forward direction with a path difference of lambda, then the phase difference between these 2 points is represented as 2 pi. Remember this condition based on this equation. Similarly, we can represent the relation between phase difference and time difference. So when the wave is being propagated in the forward direction, we consider phi 1 is equal to omega into time taken by the wave in propagate in the forward direction x, and phi 2 is equal to omega into t2 is kx. Then the path difference between these 2 points, delta phi is equal to omega into t2 minus t1. So here we get omega into delta t, where we know that omega equal to 2 pi by t. So observe that for a phase difference of 2 pi, there is a time difference of t. So based on that, here we can represent 2 pi by t into delta t. This shows the relation between phase difference and time difference. Take a screenshot, we will continue. When a mechanical wave is being propagated in the forward direction, we can represent the energy of this wave, as well as we can also represent the power of this wave, and we can also represent the intensity of the wave. So let's see the condition. So here when we consider a wave is propagating in the forward direction, we represent that the particle will execute a SHM. We know that a particle executes a SHM when a wave is propagating in the forward direction. So the particle velocity is represented as dy by dt, where the displacement of this SHM is given as y equal to a sine omega t minus kx. So on differentiating this equation, here we get a omega into cos of omega t minus kx. So this is the expression for particle velocity, whereas we can represent the maximum particle velocity. So we get maximum particle velocity when this omega t minus kx is equal to 0. So when the phase difference is 0, we can represent, when the phase is 0, we can represent that the particle possesses maximum velocity. So cos 0 is 1. So here we get a maximum velocity as a omega. So by using this maximum, we are going to represent the energy density. Energy density of a wave is represented with U. So it is being represented in terms of kinetic energy per unit value, and we know that density equal to mass by volume. So based on that, the energy density is given as half rho v square, where v represent the maximum particle velocity of the wave. So energy density is given as U into rho into a square into 1 square. This represents energy density. Based on this energy density, we are going to represent energy, where we know that energy density is equal to energy per unit volume. So then the energy of the wave is given as energy density into volume. So here the volume of a wave is represented in terms of surface area as well as change in the displacement of the wave, nothing but path of the wave. So based on that, here we can represent the energy density as half rho a square omega square into S represents the area of the wave, S into delta x. So this represents the expression for energy. Take a screenshot, we'll continue. Okay, now we are going to represent the power of the wave, whereas we know that power is equal to energy by time taken. So here we know that the expression of energy is half rho a square omega square into S into delta x by the time taken has been represented as delta t. Observe that rate of change of displacement is nothing but velocity v equal to delta x by delta t. Here this v represents speed of a wave, nothing but we also represent it as a velocity. So the power is given as half rho a square omega square into S into v, where v is the speed. Now as we consider, we have to represent the intensity of a wave. Whereas intensity of the wave is given as I is equal to power per unit area. So as we consider half rho a square, half rho a square omega square s into v by by s. Observe that s and s gets cancelled, so we have half rho a square omega square into v. So this represents the expression for intensity of the wave in terms of speed of the wave, amplitude, angular frequency and density of the medium. So we know that angular frequency is represented as omega equal to 2 pi f. When we substitute this value in the given equation, here we get I is equal to 4. 2 square is 4. 4 by 2 is 2. So here we get 2 pi square f square rho into a square v. Observe that int is directly proportional to amplitude square based on this condition. Take a screenshot, we'll continue. Whereas the relation between particle and wave velocity, relation between particle velocity and wave velocity is represented as particle velocity equal to minus of v into slope of a wave. This shows the relation between particle velocity and wave velocity. Whereas the differential form of wave equation based on SHM, wave equation based on SHM is represented as d square y by dx square equal to minus 1 by v square, so plus 1 by v square d square y by dt square. This shows the relation between coefficient of x and coefficient of t, x and t. So here we consider different wave equations, whereas equations are being represented as y is equal to a sin omega t minus kx, or we can also represent a equal to y equal to a e to the power of ax plus bt whole square, or we can also represent y equal to a by b plus x minus vt whole square. In this way we can consider any type of equation, or we can also consider y equal to x minus vt whole square, or we can also consider y equal to under root of x minus vt, or we can also represent it as y equal to a into e to the power of minus b into x minus vt whole square. So these are the different forms of wave equations in the case of mechanical waves. Take a screenshot. So let's solve a problem based on this displacement expression. Observe that the amplitude of a wave disturbance propagating in the positive x direction is given by y equal to 1 by 1 plus x square at t is equal to 0 and y equal to 1 by 1 plus x minus 1 whole square at t equal to 2 seconds, where x and y are in meters. The shape of the wave disturbance does not change during the propagation. So he asked us to find out the velocity of a wave. Velocity of the wave. So here observe that the displacement expression is being represented as y equal to 1 by 1 plus x square at t equal to 0 and y equal to 1 by 1 plus x minus 1 whole square at t equal to 2 seconds. So we are going to represent a common expression based on these two equations. So the common expression is being given as y equal to 1 by 1 plus x minus x plus vt minus 1 whole square. Observe this equation here at t equal to 0. When I substitute t equal to 0 in this equation, here we get just we modify it. So we just modify it as 1 plus x minus vt whole square. So observe that we had modified this expression as 1 by 1 plus x minus vt whole square at t equal to 0. When we substitute here, we get 1 by 1 plus x square at t equal to 2 seconds. Here we are representing it as x minus 1 whole square. When we equate these two equations, x minus 1 whole square and x minus vt whole square, here we observe that x minus vt is equal to x minus 1. So here we can represent vt equal to 1. So v equal to 1 by t. So we are going to find out the speed at 2 seconds. 1 by 2 is nothing but 0.5 meter per second. So this is the speed of the wave. Take a screenshot. Let's solve one more problem. Whereas a longitudinal progressive is given by y equal to 5 into 10 to the power of minus 2 sine pi 400 meters. So based on that, we have to find out the amplitude as well as we have to represent frequency, and we have to represent wavelength and velocity of a wave, as well as velocity of the wave and acceleration of a velocity and acceleration of a particle, at x equal to 1 by 6 meter and t equal to 0.01 seconds. As well as we have to represent a maximum particle velocity, and maximum acceleration. So let's find out. So when we compare this equation with y equal to a sin omega t plus kx, here observe that a can be represented with this equation. So the amplitude is being given as a equal to 5 into 10 to the power of minus 2 meters. Now we have to represent frequency. So when we compare this, omega equal to 400 pi t, omega t equal to, but we know that omega equal to 2 pi f. So based on that, here f is equal to omega by 2 pi. So we have 400 pi by 2 pi, nothing but frequency is being represented as 200 hertz. So now we have to find out the wavelength. When we compare this k with this pi, we have k is equal to 2 pi by lambda, then lambda equal to 2 pi by k, where the value of k is pi. So 2 pi by pi gets cancelled, so we get 2 meters. Wavelength is being represented as 2 meters. Now we have to represent the wave velocity, where we know that the wave velocity is given as v equal to lambda f. Value of lambda is 2 and f is 200. So we get 400 meter per second is the wave velocity of the wave. Now we have to represent particle velocity, where we know that particle velocity is given as a omega in terms of omega t plus kx. Particle velocity a omega into cos of omega t plus kx. So here, as we consider this equation, and substituting the values of omega a and the value of cos, here we get Vb is equal to 10 root 3 pi meter per second, and similarly the acceleration of the particle is being represented as minus a omega square into sine of omega t plus kx. So based on that, here we get a minus 4 into 10 to the power of 4 meter per second. So on substituting the values from the displacement expression, here we can get the particle and particle velocity, particle acceleration as 10 root 3 pi and minus 4 into 10 to the power of 4. Yeah. Now we have to find out the maximum particle velocity as well as maximum particle acceleration. Whereas we know that the maximum particle velocity has been represented as Vmax is equal to a omega. Vmax equal to a omega. On substituting the values of a and omega, here we get 20 pi meter per second, and the maximum acceleration is being represented as a omega square. On substituting here, we get 8 into 10 to the power of 4 meter per second square. So these are the values of maximum velocity and maximum acceleration. So thank you for watching my video. Please subscribe my channel and share this channel to your friends so that they also can understand the concepts, and they can share the ideas regarding this. Remember that cracking of IIT or NEET is not a big task. So we should concepts. So try to be perfect with the concepts. Thank you for watching my videos.